In this video, I'm going to talk about average value. So the average value of a function f of t on some interval a, b really is just asking if I were to take the total quantity that takes place over this time interval a, b and distributed it evenly over that time interval, what would that quantity be? And you can do this visually using a graph. We can see that if I were to sort of level out this function on this time interval AB, I would take some of the higher values up here and dump them down into this hole, and you could sort of draw maybe a dotted line to indicate what that average value is. And this is just an estimation based on the graph, but really all of this upper volume up here would have to measure out and equal the lower volume down here. So how do we represent that mathematically? Mathematically, an average value is going to be the sum of the total quantity under the curve, which is the integral from a to b of f of t. And then I'm going to divide it by the interval of time that has elapsed. And in this case, the difference in time values is going to be the value b minus a. Because this is a fraction, this is sort of a messy fraction, right? A nicer way or a cleaner way to write this is that the average value is given by 1 divided by b minus a, this denominator, times the integral from a to b of f of t dt. And in my head, I'm thinking to myself that this integral represents the total quantity amassed over time over some time interval, and this 1 divided by b minus a, I'm dividing by the time. Typically, when talking about average values, we do this in a contextualized situation, so for a specific quantity over a specific time. One example that you can think about is that of a velocity, and this is an overused example perhaps, but suppose I have some velocity curve, right? This is v of t, and I want to know what is my average velocity from time a to time b. And maybe this is a boring looking curve that visually I can estimate that the average velocity is going to be the velocity value that is the here. Formally, it's going to be the integral from a to b of v of t dt. And I'm going to divide by the total time period that's elapsed, which is 1 over b minus a. But contextually, this is the same thing as the integral under this velocity curve by our net change properties we've already talked about, that this value is going to be the total distance, because the integral of a rate is going to be the total distance that's traveled, and then this divided by b minus a, that's the total time. Let's look at a specific example, and maybe I should say that this is going to be equal to the velocity average over that time interval. So let's say the rate of water flow through a pipe is given by r of t equals 5t squared minus t cubed. And we want to find the average rate of flow from t equals 1 to t equals 5. So for this example, when I'm thinking of the average rate of flow, the way that I'm going to compute this is by finding the total gallons, or the total amount of flow, and then dividing it by the time period that is elapsed. And in this case, in order to compute the total gallons, I'm going to compute an integral from t equals 1 to 5 of my function r of t dt, and I'm going to divide it by the total amount of time that's elapsed. And in this case, 5 minus 1, 4, I guess, units of time have passed. We haven't, maybe I didn't even say that it was gallons either. And the way that we write this is 1/4 of the integral from 1 to 5 of 5t squared minus t cubed dt. right? Because this is giving us our total quantity, and in order to find the average, we're dividing by the period of time. So let's go ahead and compute the integral. We can compute this integral pretty readily using power rule. The 1/4 just stays out front, and I'm going to get 1/4 of raising this to t cubed, and then dividing by 3. And then I'm going to subtract the second term. This becomes 1/4 t to the 4th. And we're going to evaluate this as t goes from 1 to 5. So plugging 5 into the function, evaluating at our upper limit, we're going to get 1/4 of 5/3 times 5 cubed minus 1/4 times 5 to the 4th. This is evaluating at our upper limit where t equals 5. And now I'm going to subtract out evaluating at our lower limit when t equals 1. This just becomes 5/3 minus 1/4. So plugging this into a calculator or using some clever mental arithmetic, we can see that this first term is going to be 5 times 5 cubed, which is 5 to the 4th. So we get 625 thirds minus 5 to the 4th, which is 625 fourths. And now I'm going to subtract 1/4 of 5/3 is 20/12 minus 3/12 is 17/12. And so altogether, this is going to end up being 625 twelfths minus 1/4 of 17/12. So 625 minus 17 is 608 twelfths. And of course this fraction can be reduced, but I'm not going to reduce it because that's hard for me to do in my head. So this is going to give me my average rate over that time period.